Before the universe existed, there was no space, there was no time, there was no darkness, no light, no emptiness, because even emptiness requires space to exist within. The phrase "before the Big Bang" is tempting to use, but it may not actually mean anything at all. Time itself did not yet exist. Without time, there can be no before, no waiting, no anticipation, no silence stretching backward. The universe did not begin inside time. Time began with the universe. This is one of the most difficult ideas for the human mind to grasp, because everything we experience happens inside time. Cause before effect, moment following moment, but at the very beginning those rules no longer apply. Physics tells us that all space, all time, all energy, and all matter were once contained in a state so dense, so hot, so compact, that our current laws of physics break down when we try to describe it fully. This was not a point floating in space, it was space itself, not a spark in darkness, but the birth of darkness and light together. We often imagine the beginning as a dramatic explosion, a fireball bursting outward into emptiness. But this image is misleading. There was no empty space waiting outside. The universe did not explode into something else. The universe expanded into itself. Everywhere at once, at that first moment, the entire universe was everywhere, because everywhere had not yet been defined. What existed then was not chaos, but something deeper than chaos. A state governed by probabilities, by quantum uncertainty, by laws we are still only beginning to understand. And from that state, everything we know would eventually emerge. The Big Bang was not a single event in one location. It happened everywhere, at once. It was the moment when the universe began to expand, when space itself started stretching outward in all directions. In the earliest fraction of a second, the universe underwent a period of rapid expansion called inflation. During this time, space expanded faster than the speed of light. This does not violate physics, because it was not matter moving through space faster than light. It was space itself expanding. Tiny quantum fluctuations, microscopic differences in energy, were stretched across the universe. These faint irregularities would later become galaxies, stars, and everything that would follow. At first, the universe was unimaginably hot, so hot that no atoms could exist, so dense that even fundamental particles could not yet combine. Energy dominated everything. As the universe expanded, it began to cool, and cooling changed everything. As temperatures dropped, the first fundamental particles began to form. Quarks combined into protons and neutrons. Electrons appeared. But something strange happened. For every particle of matter, there should have been an equal particle of antimatter. When matter and antimatter meet, they annihilate each other in flashes of energy. If matter and antimatter had existed in perfect balance, they would have destroyed one another completely, and nothing would remain. But for reasons still not fully understood, there was a tiny imbalance. For every billion particles of antimatter, there were 1,000,000,001 particles of matter. That single extra particle, that tiny asymmetry, is the reason anything exists at all. When matter and antimatter annihilated each other, that slight excess of matter survived. Everything you see, every star, every planet, every cell in your body, exists because matter won by the smallest possible margin. As the universe continued to cool, protons and neutrons began to combine. Within minutes, the first atomic nuclei formed. Hydrogen, helium, tiny traces of lithium. These were the simplest elements, the building blocks of everything that would come later. But the universe was still far too hot for electrons to attach to these nuclei. Without electrons, atoms could not form. The universe remained a glowing, opaque plasma. Light existed, but it could not travel freely. Photons bounced endlessly off charged particles, trapped in a dense fog of energy. For hundreds of thousands of years, the universe was bright, yet completely opaque. No stars, no galaxies, no planets, just a vast glowing sea of particles and radiation. All structure was still waiting to happen. Gravity was already at work, quietly shaping the future. Regions with slightly more matter than average began pulling in surrounding material. These differences were tiny, but over cosmic timescales, tiny differences matter. They always do. About 380,000 years after the Big Bang, the universe cooled enough for something remarkable to occur. Electrons slowed down. They were finally able to attach to atomic nuclei. The first true atoms formed. Hydrogen atoms filled space, and suddenly, the universe became transparent. Light was no longer trapped. Photons were free to travel in straight lines for the first time. That ancient light still exists today. It surrounds us. We detect it as the cosmic microwave background, a faint glow coming from every direction in the sky. It is the oldest light we can observe. A snapshot of the universe as it was when it first became visible. After this moment, the universe entered a long, quiet era. An age without stars. An age without light sources. An age known as the Cosmic Dark Ages. For hundreds of millions of years, the universe was filled with neutral hydrogen gas and slowly growing gravitational structures. No galaxies yet burned, no suns yet shone. But gravity never sleeps. Across immense spans of time, matter continued to gather. Clouds of gas slowly thickened. The seeds planted at the beginning were finally preparing to awaken. And when they did, the universe would never be dark again.